Okay, so we're continuing on with lesson one. We're going to talk about what is physics and get into our first kind of activity, which we'll simulate from my house. So what is physics? So this is generally a question that people have different answers to. So people come up with the actual, definition from, Webster's or whatever. But really, I'm not so interested in that. And sometimes classes are hesitant, so I give them some multiple choice options. So some people feel like that's probably the best answer for them. So it's a class they need for their major. Education majors need this class. Not sure why, but they do. It's a class about life, so maybe it ties in with your everyday life. And it's a difficult class. So those are generally some options that I give, and I let people select out of those three. And it kind of depends on what your situation is. So if you are an elementary ed major, you have this class and it's required. And a lot of elementary education majors leave this till the very last of their courses, so they're like nervous to take it. If you need it for your major, you're going to be motivated to work and get the work done. Again, if you're doing the work, I would say the majority of the people that do the work and they are proactive and advocate for themselves, they pass the course. So hopefully you're going to be one of those people, and it'll be fun. A class about life. Physics is probably the biggest science class that relates to everything. So like it just describes how the physical world works. So in any instance where you are physically interacting with something else in this world, physics is going on. So we're trying to describe how that interaction is taking place, what's happening. There's lots of different aspects of it. It happens in every part of your life. So what's great about physics is I can tie it into pretty much any topic and your own personal experience. So you are living physics every day. So if we're doing a situation where we're talking about you're driving in your car and something as you turn left, your books or purse or whatever slide over to the right side of your car, that's something we explain with physics. We talk about why you get shocked when you walk across the carpet in wintertime with your socks on and you touch the door handle. So like it's all these different ideas, but physics actually tries to simplify things. So we try to use the same rules and the same ideas in a lot of different concepts. And I really like it that way. If you can understand chemistry, if you've done chemistry or biology, there's physics in those too. So it's just kind of understanding how that all comes together. And it's a very concrete, real life based science class. So it's not, my problem with chemistry when I was taking chemistry is it was so small, everything's so small, and you just imagine it and you sort of see these results of it, but you can't really see what's going on. In physics, it's real life stuff. It's stuff that we deal with every day, so we can talk about it. And not all physics that way, but the physics in this class is definitely that way. Difficult class, again, I try to make it as straightforward and simple as possible. I feel like over my 20 years of teaching this, of physics, I have developed a way that most people understand the way that I express it. So some people read textbooks and they get the material out of textbooks, and that's fine. I was not that kind of person. I was much better when somebody kind of sat with me and talked with me or talked about the topic with me, and I was allowed to ask questions and they would show me what to do and I would figure it out. And that's the way that I try to model this class. So again, we have some restrictions with our current situation, but we will do our best to kind of get through it and to help you in any way that I can. So if there's a way that works better for you, if you let me know, I can try to adapt the class to make it so that it is best suiting your learning modality. So anyway, that's kind of just the background. And in physics, we look at how we express ideas lots of different ways. So you'll be asked to do all of these different things across the course, and you're going to describe and explain how things work through writing out very short, brief statements or a paragraph describing what's going on. Drawing pictures. So a picture again is worth 1,000 words. That's the expression. So sometimes a picture just makes sense and it helps people develop ideas better. You're going to set up tables. You're going to collect data from experiments, simulation kind of experiments. I'll help you collect data and stuff that we're trying to do, more of like I'm demonstrating it, and you'll take the data and use it. You're going to make graphs and charts and be able to interpret those types of graphs and charts. And then we're going to also do math. So like pretty early on in this class, we will hopefully tie in these graphing ideas that you're going to use in this next activity to mathematical formulas. So like understanding how the math ties into the idea. But again, the concept is really what you're trying to get across. So sometimes it's just easier to explain a concept with math. So you'll eventually, I think, see how it's not so hard to deal with the math. And again, I try to keep it on a fairly basic level where everyone is comfortable doing the kind of math that I require. And if there's anything that's a little bit trickier, I spend time with it. So I will make sure that I teach you the math that you need to be able to get through. Okay. So the first thing we're going to try to do is an activity, and we would normally do this in class. And it would take a lot longer because I would give you guys a lot more time to kind of ask questions and work through it on your own. But in this activity, we're going to start with a phenomena that you might be familiar with. So it's just a ping pong ball. So you guys are all college students, and at some point you attended high school, and you probably are familiar with a ping pong ball and the way that it bounces. So we're going to start to analyze in physics in a very scientific way, try to look at what are the things that we can measure about how the ping pong ball is going to bounce. So what can you describe about the bounce of the ball? What factors affect that bounce? And I would give you guys time to kind of talk about it amongst your groups and determine what you wanted to try to experiment with. And then I would ask, okay, well, what would you need in order to measure that information? So to collect data, to develop a relationship between the factors. So like this is the factor we want to analyze and how it's going to affect the bounce of the ball, and what we need to use, what tools do we need to measure that. So then once we got that data, we would try to come up with what's the best way to display this data and show that relationship. And then we would have to kind of talk about the graph and decide, well, what is that graph showing? What are the factors? Like, what does the slope mean? What are the intercepts, et cetera, things like that. And you guys should be familiar with those terms. And then actually not just relying on math, but like talking about what that graph is showing. So writing out a sentence or two describing the characteristics of the graph, and you're gonna have to do that. And then, developing an equation from your data. And even before that, we would make a prediction. So we would like predict what we think is gonna happen. So the activity that we all kind of generally come to eventually is one where you're going to take a ping pong ball, and you could try this at home if you want and collect your own data, but you might not have a ping pong ball at home. So if this is my ping pong ball up here, we're going to drop it from some height. And then it's going to rebound. It's going to hit the floor or the table or wherever you're dropping it on, and it's going to bounce back up, and it's going to rebound to a new height. So originally, again, I will just say the drop height. We're going to compare the drop height to the rebound height. And if you had to make a kind of general statement like, okay, what do you think is the relationship between the drop height and the rebound height? Most people and groups come up with the idea that as you increase the drop height, if you filled in this blank, the rebound height does what? And most people say that it increases, and that is what we're gonna study. So that is sort of our prediction, and we're gonna see how the drop height affects the rebound height. So I would give you guys ping pong balls and meter sticks to kind of measure those things and collect data, and then you'd make a graph, and we'll do that. So you're gonna do the graphing part. I have collected data with my daughter's help videoing. So Abby helps out with this, and you're gonna try to plot this data. So what I'm gonna do is I'm gonna pause the video here, and I'm gonna import the video of me dropping the ping pong ball from various heights, get you some data, and then we're gonna talk about what to do with that data. So let me stop recording for a second. All right, so we're back. So we introduced the ping pong idea, and later on you're going to see when you watch this video that I recorded data, so you have that. We were postulating that if you drop the ball from a higher drop height, then you would get a higher rebound height. And we collected data, and we're going to now kind of analyze the data in a graph and think about like what we're going to graph. So this sometimes is the hardest part for people, is to make graphs. So what we're going to do, and what I suggest you do when you have the availability to do this, is to use this program on the internet at a site called Physics Aviary. So this is a site, it runs on everything, it's HTML5. So it runs on all the stuff you want it to, like your phone or your MacBook or whatever, you know, device, it doesn't really matter, your tablet. And I just type in Physics Aviary, which is up here in Quick Graph, and this is what comes up. So what it does nicely is you just enter in your data, and it'll plot the points for you. So you don't have to worry about getting out graph paper or trying to figure out a scale or anything like that. And it will let you, you know, make a title. So the thing that you changed, or the thing that we changed in this was drop height. So we did the drop height, and I measured in meters. So I'm going to put a little M there for meters. And then the thing that changed was the rebound height. So how high the ball bounced up to is what we're establishing as the rebound height. So as you can see, it changed the axes, and it just has a 10 by 10 scale right now, but as we change our data, that'll automatically adjust. So it doesn't really matter what order you put in your data points, but our first one, we dropped from 1 meter high, and it rebounded to 0.65. And again, that video did not import, but it did that. And then we dropped from 0.8, and it was 0.56. And then it was 0.6 and 0.43 was the rebound height, and then 0.4 and 0.29. And then finally, 0.2 was our initial drop height, and 0.14. And you could probably surmise that if you dropped it from 0 height, what's the bounce going to be? It's going to be 0. So I'm going to put in a data point 0, 0, because it makes sense that it goes through that point. So I have my data there, and if I just look at my data, that's the trend. So that shows what's going on. So if you think about it as we go across on this drop height, so as we increase the drop height, you can see that you have an increase in the rebound height. So that makes sense. And you might say, okay, well, what kind of relationship is that? And that's what we try to analyze a little bit deeper. So I'm going to go back to the previous page, and there's this thing that says curve fit here. So we can curve fit, and we can apply all these different kinds of relationships. So if I try a linear curve fit, which is like a direct relationship, so if it varied 1 by 1, it didn't have a bad correlation. It's actually pretty good, but you can see that there's a couple data points that are a little off the line, and that's sort of our trend. Maybe we'll try a squared kind of trend. Okay, so that didn't work. We do square root. That didn't work exactly well. So it looks like this linear trend in our data is what we see. And it already puts the equation up there. So if I go back to the big screen with it, it has your like y equals mx plus b equation. So if I just take a maybe photo of that with my tool on Smart Notebook, let me do that. So you're seeing this screen still, which is fine. I'm going to capture that screen, and it has all our data there, or at least our trend. Send the current Smart page. All right, and then I'm going to go back in. I'm going to go back to New Share and go back to our Smart Notebook. So hopefully you're seeing this now on your screen. Let me make sure that you are. So I'll stop sharing and I'll share again. Yeah, that's what we want to share, because I don't want to talk and you not see what's going on and I have to re-edit it, which I've done a couple times already. So let me shrink this up a little bit so it fits on one screen. Hopefully. There we go. So let me shrink it. So there's this definite trend that as we increase the drop height, the rebound height increases, which what we would expect to happen. So let me take this over to the next page, because that's where the questions are. So back one. All right, so we concluded, and this is sort of what we do in physics a lot. We'll just kind of look at a relationship and we'll kind of try to quantize it. So quantize it means give it numbers. So you probably have this idea already that, like, yeah, if I drop it from a higher position, we'll get a higher rebound height. So that's what what we found. So what we did, we dropped the ball from different heights and we measured how high it rebounded to. What did we find? We came up and verified our hypothesis, or we had data that supports our hypothesis that the higher you drop the ball from, the higher it'll bounce to. I would assume that other groups always find similar. And then, yeah, there's enough evidence. When we talk about the graph a little bit more, though, let's talk about a couple other ideas. So the slope, what does the slope tell us? So, and we're going to do this on a couple different graphs coming up later in the lesson, but the slope tells us how much the y variable changes with a lot of stuff on my computer, I think, going on. So let me close out a couple things that might help. There we go. With a change in. So if I wrote that out in terms of what we actually did, it's so 0.6643 is the slope, and that's meters per meter. So for 1 meter in the x. So there's a 0.6643 meter change in the rebound height for every 1 meter change in the drop height. So instead of putting in x and y, which you're used to in math class, because it's like the slope of the line, or m is change in y divided by change in x, or y2 minus y1 divided by x2 minus x1. I'm just putting in the ideas, and that's more important to us in this class, is the ideas. Like, having all these numbers is great, and in math class you had to do the slope of a lot of different probably lines, but like, what is that slope physically telling us? That's what it means. So that's the slope here. This is our y-intercept. So that means at a drop height of 0, it should bounce up to 0.01 meters, which is like 1 centimeter. So that's just how the line fit based on our data. We would expect it to go through 0, 0, because it doesn't make any sense if I didn't have the ball above the ground any. It's not going to bounce up just by itself. So there's a little bit, obviously, difference here, and that's not exactly perfect with our data, but it's what the graph shows. So the correlation 0.997, that means it's 99.7% accurate for our data, which is really good. So it shows what we expected it to show, and that's kind of what we're doing. So we're going to look at kind of plotting data, looking at the slope. What is the slope telling us? What does the y-intercept tell us? And that's going to be a skill that's useful on lots of different questions throughout the class. Okay, so that kind of wraps up the ping pong ball activity, the first activity that we would have done in class. And we're going to start getting into motion next. So let me stop sharing the screen and pause here, and I'll say have a good one, and I'll be back shortly.